Okay, so today we're continuing on with chapter 6. Today we're going to learn how to multiply polynomials. We will be multiplying monomials and binomials. So here's just a quick review. Whenever you have a number and it's got an exponent on it, 3 to the second power, that just means 3 times 3, which equals 9. For number 2, 2 times 2 times 2 times 2. I could do 2 at a time. 4 times 4, 16. Down here at the bottom, this is a review for when you're multiplying numbers that have an exponent and they have the same base. You are going to take the exponents and add them. So when I add 3 plus 4, that's how they got the 7. When it's a power to a power, you multiply them. And then here is a review for distributive property, -4 times x and -4 times -7. And that will give you -4x plus 28. And again, adding the exponents, you get 9. Power to a power, you multiply them. Okay, so today we are going to learn how to multiply polynomials. So we're going to be using the same properties that we learned about the exponents at the beginning of the chapter. So we will be applying those. So here is our first examples, and we're multiplying two monomials here. When you multiply two monomials, you are going to multiply the coefficients, so 6 times 3, and then you are going to add the exponents on the variables. So 6 times 3 gives me 18, and then y to the third plus y to the fifth, when I multiply them, I'm adding them and I get y to the eighth. Then for the next example, you're going to multiply the coefficients. So 3 times 9, and I get 27. And then I'm going to add the exponents on the m's and add the exponents on the n's. Okay, this m has a 1, so 1 plus 2 gives me the 3 here. And this 2 plus a 1 on this n gives me 3. Let's try another example. I actually have 3 monomials here. So for here, I'm going to have the 1/4, and I'm going to rewrite this so we can sort of see the work here. So we have 1/4 s squared t squared. Then I have an st here. And then I have a -12 st squared. So what we're going to do here is we're going to multiply all of the coefficients. So I'm going to multiply 1/4. This has got an assumed 1 here. Times -12. When I multiply positive 1/4 times 1 times -12, I can put them all under 1. I can actually simplify on the diagonals, and then I end up with -3. So for my coefficient part of my answer, I'm going to be multiplying this and the assumed 1 that's there and get -3. Then I'm going to go back and I'm going to look for all of my variables that have the letter S. So I have 1 here, 1 here, and 1 here. Notice these two here. This has an exponent of 1, and this also has an exponent of 1. So 2 plus 1 plus 1 gives me s to the 4th. Then I'm going to go back and I'm going to get all my t's. I have a t squared, a t to the first, and a t to the second. 2 plus 1 plus 2 gives me t to the 5th. And that's your answer. So when you're multiplying, you're adding the variable exponents, but multiplying the coefficients. So here again, when you multiply something with the same base, you add the exponents. Bless you. Here's another one. 3x to the third, and again, parentheses mean multiply. I'm going to multiply my coefficients. The 3 and the 6 gives me 18. And then I'm going to multiply the x to the third times x squared. And when I multiply variables, I add the exponents. Okay, for part B, I have 2 r squared t, 5 t to the third. Again, you're going to multiply the coefficients and get 10. Add the r's. There's only one r, so rewrite it in the answer. And then go back and add the t's. I have a t to the first and a t to the third. So 1 plus 3 is 4. Everybody good on the monomials? You guys done this before? Probably. Here's another example. You will potentially have fractions on the quiz next week. You are scheduled for a quiz on this lesson and on 6-6 on Monday. So be aware you have a quiz scheduled for next week. It will be the first quiz of the 4th quarter. Okay, so here again, we're going to multiply our coefficients, so 1/3 times 12, and they've actually grouped it for you. And actually I could do this in red like they did. So let's color code like they did. So the first ones, they got the coefficients, and then they put it together and they multiplied it. 1/3 times 12 is 4. That's how they got that answer. Then they went and they got all the x's. So an x squared, an x to the third, no x in the last one. So just the x squared and the x to the third. You add them and get x to the fifth. Then next we have the letter y. I have a y here and a y here. Nothing in the middle. Y to the first times y to the fourth gives you y to the fifth. And then lastly, the z's. They did it in purple. I'll do it in yellow. So then here, put them together, and 2 plus 5 is 7. Okay, to multiply a polynomial by a monomial, we're going to be using the distributive property. Now, before in the past, when we've seen distributive property, it's been something like 4 and then an x plus 2. Now, when we're multiplying, this monomial out here could have variables with it. And we're going to distribute the coefficient along with the variables. So here they're starting off easy for you. And all they're doing is distributing the number 4. So 4 to the 3x squared, 4 to the 4x, and then 4 to the negative 8. So here when you did it to the 3x, they got 12x squared, then the 16x, and then positive 4 times negative 8 gives you negative 32. Just like when we did on the test on Friday, if there's no like terms, you just leave everything separated. If there were like terms, we would group them and simplify. Here's another example. Now, not only is it a constant outside, we actually have some variables with this 6. So here are my two, my monomial times my polynomial. I'm going to distribute the 6pq. First, it's going to go to the 2p. So just like we did before, I'm going to multiply the coefficients. And then I'm going to add the exponents on the p's, nothing to add to the q. And then now I'm going to distribute it again, but this time to the negative q. So then that will give me negative 6. There's only one p, but 2 q's. And you leave your answer like that. Okay, p to the second here and q to the second, these aren't like terms. So this has a p squared q at the beginning, and this has a pq squared. So you would leave them apart. Okay, next we're going again to distribute this to both of the terms. And again, we're doing half of 6 and half of 8 for the multiply of the coefficients, and then add the variables. Here again is just a constant times the polynomial. So first the 2 will get distributed to the 4x squared. That gives you 8x squared. And then the 2 will go to the x, and then 2 to the 3. And that's your final answer. No like terms to group, you stop there. So you can multiply a number and a variable, okay? Before we couldn't add them unless they were the same, but when you multiply, you can. Here's another one. Again, lots of practice here. This is going to be the foundation of everything, so you must understand the difference between adding and subtracting and multiplying. And then we're also going to be getting into dividing. So again, 3ab is my monomial that I'm going to distribute to my polynomial here, my binomial. So I'm going to distribute 3ab to the 5a squared, and I get 15a to the third b, because I add the a exponents, and then I'm going to distribute it also to the b, which gives me 3ab squared. Here's another example. Again, take your time, watch your signs. So see how this is a subtraction sign here. So when we distribute it to the 3s, you can either think of that as a negative or distribute, put in the negative sign at the end. Now we're going to look at binomials. Okay, this is where we can introduce the acronym FOIL. Now, technically, the whole process of FOILing is just distributive property, but it's a little way to help you maybe make sure that you're not forgetting anything. When we multiply binomials together, we are going to have some like terms that we are going to have to group. It's always going to be the two middle terms after you apply either the distributive property or the FOIL. So for example, if I took this problem, x plus 3 and x plus 2, and if I were to not use the acronym FOIL yet, but just do distributive property, the process is as follows. You will first distribute the x to both of the terms. So again, x times x, we add the exponents, I get x squared. Then when I distribute the x to the 2, it becomes 2x. Now I have to distribute the 3 to both of the terms. So 3 times x gives me 3x. Then the 3 gets distributed to the 2, and I get 6. They're showing here the multiplication and what they did when they distributed. Now, at this point, we're not finished because we do have some like terms here in the middle that we can put together. So I'm going to rewrite the x squared. I'm going to add the 2 and the 3, and then put the 6. That will be my simplified answer of multiplying these two binomials. This is just using distributive property. You just must remember to distribute each monomial to each term of the second binomial. Here is the acronym FOIL. So each one of the letters in the word FOIL stand for a step in the process. The F in the word FOIL tells you to multiply the first term in each one of the binomials. So I'm multiplying x times x and getting x squared. The letter O in the word FOIL represents the outer terms or the outside terms. So here the outside terms are in blue. They're x and 2. When you multiply x times positive 2, you get 2x. Then the letter I in the word FOIL represents the inner terms. So when I do 3 times x, I get 3x. And then when I multiply the two last terms in each one of the binomials, that will give me 3 times 2, which is 6. Notice, using either method, distributive or FOIL, I still have 2 middle terms that I need to group. And then my answer is exactly the same. So essentially, using the acronym FOIL is really doing distributive property. But it's a little way to help you remember the order to do it. So again, you could write it out as x plus 3, x plus 2. So again, first are those guys. Then outside or outer would be those. Those are the outside ones. And then the inside ones would be here. And then the two last ones would be the 3 with the 2. And that's the acronym FOIL. But again, it's just applying distributive property. Let's try another example. Now, when the signs are different, you need to take your time and watch your signs. So S plus 4 and S minus 2. So again, let's go through, let's try the acronym. So first, yes?
When you combine like terms, you just do it like that, or just the bottom?
Yes, right there. So S squared is my first. My two outer ones are going to be negative 2 times positive S gives me negative 2S. Then when I do the two inside or the inner ones, I get positive 4S. And then finally last, positive 4 times negative 2 gives me negative 8. So if there's a subtraction sign in your binomial, you're going to have a negative number in there. So unless both of them are negatives, then negative times negative becomes positive. So I need to group my middle terms. The S squared stays the same. My two middle terms, when I do negative 2 plus 4, gives me positive 2, and then the negative 8 drops. Everybody good on FOIL? Let's do some examples. Now, this is an example of a binomial squared. So whenever you see this, remember to the second power, all that means is write it 2 times and FOIL it or distribute it. So notice here, I've got 2 subtraction signs. So that's going to make my last term positive, but my middle term is going to be negative. So when I go to do here, I'm going to go, the first is x squared. My outside terms gives me negative 4x. My inside terms give me negative 4x. And then finally, my last is going to be negative 4 times negative 4, which gives me positive 16. I'm going to add my middle terms. So my first term, my x squared, drops. My middle term now becomes negative 8x. And then I drop in my last term, nothing to group with it. And that is multiplying a binomial squared. Here are some binomials with a little bit more complicated. We got 2 letters going on here. But again, the process is the same. So let's try it. So I have m to the second power, 8m to the second power, minus n, m squared minus 3n, and now I'm going to FOIL. So first, 8m to the 4th, I'm adding those exponents. Then my two outer ones become negative 24 m squared n. And then the two middle terms, notice there's no letters to combine, so I'm just going to write them together. So m squared n. And then last gives me negative n times negative 3n makes it positive 3n squared. And again, notice you got some middle terms here that you can group together. Assume a 1 in front of here. So 8m to the 4th minus 25m squared n, and then plus the 3n squared. So generally, it's going to be a trinomial as your answer. So again, here, when you have a binomial and it's raised to the second power, just rewrite it 2 times and either distribute it or FOIL it. Here's another example. Again, you're going to distribute, and now they're going back to the distributive property. But again, it's the same thing if you FOIL. First gives you a squared. Outside or outer gives you negative 4a, which is right here. The inner gives you positive 3a. And then last, positive 3 times negative 4 is negative 12. Again, group the middle ones, giving you the negative a. Again, a binomial squared. So again, rewrite it, write each one 2 times, and then FOIL or distribute. Another example, again, they're using the FOIL method, first, outer, inner, last. Again, they had 2 middle terms to group, and it becomes 7ab squared. Now we're actually going to have a binomial times a trinomial. The acronym FOIL will not work here. So all we're going to do is use the distributive property. So let's try this. Gets kind of long. So if I have 5x plus 3, and then my trinomial that I'm going to multiply it with is 2x squared plus 10x minus 6. So first I'm going to distribute the 5 to all 3 terms. So when I do that, I get 10x to the 3rd. And then when I do 5x times 10x, I get 50x squared. And then when I do 5x times negative 6, I get negative 30x. Now I'm going to shift to the positive 3 and distribute that to each one. So 3 times 2x squared gives me 6x squared. Then 3 times 10x gives me 30x. And then 3 times negative 6 gives me negative 18. Now, when we're doing a binomial times a trinomial, there's going to be more than just 2 terms to group. So notice, I only have x to the 3rd, so I'm going to rewrite that one. But when I go back and look for my x squareds, I got a 50x squared here and a 6x squared here. So those will get grouped together. I also have some like terms here, and they will cancel out. You do not need to write 0x, you just leave it out. And then nothing to group with the 18, so you'll just write that in the answer. So you're going to need to take your time. watch your signs and be very neat. This is a rectangular model method. You don't need to demonstrate this to me. I prefer you either use distributive property or FOIL. Okay, when your problems get more complicated, you're not going to have time to draw out these boxes. Okay, here's another method to multiply. It's the vertical method. If you prefer to do it this way, you can. Chances are it's not going to ever be presented to you in this format. You would have to rewrite the problem yourself. So again, here's another example. Let's try it. And I'm just going to use distributive property. So I have x minus 5. And I'm asked to multiply that to x squared plus 4x minus 6. So I'm going to distribute the x first. So x to x squared gives me x to the third power. X to the 4x gives me 4x squared. Then x to the negative 6 gives me negative 6. Now I'm going to distribute the negative 5, and I treat this as a negative 5 times x, negative 5 times 4x gives me negative 20x, and negative 5 times negative 6 gives me positive 30. Notice again, I've got some like terms here. So I've got some x squareds that I can group. So I'm going to group this one and this one. But let me start by writing my x to the third power. Then my x, because 4 minus 5 is 1, negative 1. And then now I'm going to group my x's, negative 6 and negative 20 gives me negative 26x and nothing to group with the 30. And that will be your final answer. Here's another example. They're showing it vertically. Again, I prefer to see you do it using distributive property. Now, if you have a binomial that's cubed to the third power, we're going to write it 3 times and FOIL it. So we're going to actually just take it. I recommend you do it 2 at a time. So if you have x, let's do it in black, x plus 3, x plus 3, x plus 3. That's how I'm going to translate x plus 3 to the third power. So what I'm going to do here is I'm going to first take these.
Or come down to student services, please.
Who is it?
Christiana Tenor.
Got it. All right, thank you. Okay, so I'm going to FOIL the first 2. And I get x times x is x squared plus 3x. So first, outside, inside, last. Okay, now I still have this one over here. I'm going to simplify this. And then I end up with x squared plus 6x plus 9. And then I have the x plus 3. Now I have to distribute. I'm going to go ahead and write this binomial in the front. Doesn't really matter, but it'll make it easier. So I'm going to flip them around. I'm going to apply the commutative property here. So now I'm going to distribute x to the x squared, x to the 6x, and x to the 9. Then I'm going to distribute the 3 to the x squared, the 3 to the 6x, and the 3 to the 9. And now I'm going to go back and group my like terms. Nothing to group with the x to the third. I can group an x squared here and an x squared here. And then go back and grab the x's. So 9 plus 18 gives me 27x, and then plus the 27. So if you've got more than 2, take them 2 at a time. Get an answer, and then distribute it with the next one. So here's their finished product, and I got the same answer. Here again is using their columns and their boxes. Again, you don't need to know this method. I just recommend you distribute, and then distribute, and then combine your like terms. So here, a helpful hint. So a polynomial with m terms multiplied by a polynomial with n terms has a product before simplifying has mn terms. So an example previous to this, if there are a 2 times 3 or 6 terms before simplifying. So notice here, to apply that, this binomial has 2 terms, this has 3 terms. So if I do 2 times 3, before I simplify my like terms, notice after applying distributive property, I've actually got 1, 2, 3, 4, 5, 6 terms. So that's all that they were saying on that previous slide, is before simplifying, you should have the number of terms that you would get if you multiplied the number of terms times the number of terms. Again, here is that vertical method. Again, I don't expect you to demonstrate that. Either use just no distributive property. And here is an application. It's a word problem. Here it's saying the width of a rectangular prism is 3 feet less than the height. The length of the prism is 4 feet more than the height. Write a polynomial that represents the area of the base of the prism. So if you read here, 3 feet less than the height. So that's why they did h minus 3. And then for here, 4 feet more than the height, that would be adding, and then they FOILed it because area is length times width. And again, here is their FOILed answer. And then part B of it said, after you FOILed it, do it and plug in 5 for the height. And then here is the length of the rectangle is 4 meters shorter than the width. Again, formula for area is length times width. So if you're going to let the width be x, and the length be x minus 4, then you just FOIL, or not FOIL, you distribute. And again, if they didn't give us a value for the length or the width, we would just leave it with variables. And that worked out. And here's some more examples. So you do have homework tonight. It is practice A. Tomorrow we will reinforce this. We will do extra practice of this because this is really the foundation of everything, and it's going to get more and more difficult as we go through. So it's going to be very important that you have a good foundation for multiplying monomials and polynomials. So you can go ahead and get started on your practice A, and if you have questions, you can come and ask. Also, if you have any questions about your test, you can also ask me about that.